Okay, now welcome back. Let us do another numerical problem on on pulley systems. And this time we have a fixed pulley. This one is a fixed pulley fixed to this support here, and this is a movable pulley. Since both are not fixed, so the acceleration of this mass and this mass will not be same. And the level of this question is slightly more than for NEET examination. So what I suggest, at the most, if you are an aspirant for NEET 2021 and thereafter, go up to maximum this level of questions, not beyond that. But you can expect such type of questions in JEE main examination mostly, where there is a fixed pulley and a movable pulley. Now look at the diagram. This pulley is fixed, this pulley is movable, and this pulley is attached with a mass here. Let this mass is equal to M1 and this mass is equal to M2. And in your examinations, competitive examinations, the value of M1, M2 will be normally given. And the pulleys, the mass of the pulleys are neglected, and the string, this string which is fixed here, passes over this pulley, and finally it is attached with a mass M1 here. Now the question is, if M1 is heavier than M2, then M1 will come down, M2 will go up. If M2 is heavier than M1, then M2 will come down and M1 will go up. Without doing anything, you can well imagine if M1 is coming down and M2 is moving up, if the acceleration of M2 is A, let me write it here. If M2 is moving up with an acceleration A, then M1 will move down with acceleration 2A. I will explain that how. So let us discuss. Now, what I am taking, I am considering in this situation as M1, the value of M1 is more than value of M2, so M1 will fall down and M2 will move up. So in that situation, this is the central part. This line refers to the central part of the pulley. Suppose this pulley moves up. The central point of this pulley, which is here, comes here. Means the new position of the pulley is this. So what will happen? So in that situation, this string will no more remain like this, will no more remain like this. This string from this point will take a turn around the pulley, then move over this pulley and will come down. Means if the distance from here to here by which this pulley has moved up, that is from here to here, is x, then this much of this length of the string and this length of the string, that is x plus x, will be available on this side. Means if this pulley moves up by a distance x, the length of the string that will be shortened on this side, that will be x plus x, 2x, and that 2x length of string will be available on this side, x plus x, that is 2x, and the whole process will happen in the same time, at the same instant. Means if the acceleration of this is A, then the acceleration of this to this side will be 2A. If the velocity of this pulley to this side is A, the velocity this mass is attached to this pulley. So if this pulley is moving up with an acceleration A, this mass M2 will also move up with acceleration A. and this mass will fall down with acceleration 2a. Let me explain you once more. Suppose this m1 is heavier than this, so this length of the string, which is fixed, will keep on increasing to this side and will keep on decreasing on this side. Suppose this pulley at some instant is here. So what length of this part of the string? What length of this part of the string has decreased? From here to here, if it is x on this side and on x on this side, x plus x, 2x. The decrease in length of the string on this side is 2x. So same is the increase of length of this string on this side to keep the total length constant. So now it is clear why the acceleration of this will be 2a and that of this will be a. Similarly, if this comes down and this goes up, then its acceleration will be a to this side and its acceleration will be 2a to this side. In this situation, I have taken m1 is falling down because m1 is heavier than m2. Then now let us write the equations and solve it. So its weight is m1g. Here is the tension T and this is coming down. m1g is exactly opposite to this. So the net force on this will be m1g minus T. That will be its mass times acceleration. And if you look at here, here is the interesting part. This is T. So this is also T. Here the tension is also T. Away from the pulley. Here also the same T. Now this pulley is being pulled to this side on both sides by T and T. So here the tension will be 2 times T. Now I am interested in the acceleration of this mass. So its weight is vertically downward m2 times g, and this is moving up with acceleration a because this is fixed with this pulley. So the equations of motion for the first one, since this is coming down, will be m1 times g will be m1g minus t is equal to its mass into acceleration. Its mass is m1, acceleration is 2a. This is what I just explained. So is equal to m1 times 2a, equation 1. Now if you rewrite in a decent manner, it will look like m1g minus t is equal to 2 times m1a. Fine. Now then look at this. This is moving up. Just look at this. Don't look here. Because we are interested to find the acceleration of this. 2t is vertically up, m2g is downward. So 2t minus m2g is equal to its mass m2 times its acceleration a. Now here, as we did before, when we were adding the two equations, t was getting cancelled and we are getting the expression for acceleration. Here if you add, the t will not cancel because here it is 2t, it is t here. So what do? I multiply this equation with 2. So 2 m1g minus 2 times t is equal to 2 times this, that is 4 times m1a. And I keep this equation as such just below it so that I can subtract 2t minus m2g is equal to m2a. So let it be 3 and 4. These are your new equations. Now add these two equations. So minus 2t plus 2t, they cancels. On this side, on the left hand side, you can take g common. So you are left with 2m1 minus m2 times g on the left. On the right hand side, if you take a common, we are left with 4m1. I'm adding it plus m2. So your acceleration comes out to be, now this is multiplied, it will come to this side, it will be divided. So 2m1 minus m2 over 4 M1 plus M2 whole into G. Now, if you put this value of acceleration either here, either any one of these equations, you will find out the expression for tension. So let me put it here. Let me put it here. Let me bring this equation. You can put anywhere. Let me bring it here and rewrite it. M1G minus T is equal to 2 times M1, 2 times M1 times this acceleration. So I put the value of acceleration here, 2M1 minus M2 over 4M1 plus M2 times G. Now we are interested to find this tension T. So I take this to the right hand side. So this becomes positive and bring this to the left hand side. So we are left with M1G minus 2M1 within bracket 2M1 minus M2 over 4M1 plus M2 times G. This is one term, this is another term. So you can take common. You can take G common. Let me put in another piece of paper. So then let me take a paper, pause the video. So I have got a new paper now. It's a paper. So well, you can see here. So your T is equal to G take common. So we are left with M1, or you can take M1G also common. You can take M1G common, that will be more better. So, okay, let us take T common only, G common only. So you are left with, in the first term, M1 minus 2M1 within bracket 2M1 minus M2 over 4M1 plus M2. G is already taken common, right? So now you have to simplify this to make it, so T is equal to G times M1 minus, this will be multiplied here and here. So this will be multiplied here and here. So 2 2s are 4 M1 square minus, this will be multiplied here, 2 M1 M2 over 4 M1 plus M2. Now, so your T comes out to be, now this is the denominator, so your LCM is equal to 4 M1 plus M2. So this becomes, comes here, 4 M1, 4 M1 square, then this comes here, plus M1, M2, then there is a negative sign here, so I have to be careful, 4 M1 square, minus plus, so this becomes 2 times M1, M2. Now, so that is equal to G times plus 4M1 square minus 4M1 square cancels, 2M1, M2 plus M1, M2. So that is equal to 3 times M1, M2 over 4 M1 plus M2 is your tension. So your T is equal to, keep G on this side, let this looks better, 3 M1, M2 over 4 M1 plus M2 times G is your tension, right? Is your tension. Now, so So that is all about. I hope it is clear to you. But such a lengthy question you won't get in NEET examination. But they might ask you. What is the ratio of the acceleration of this mass and this mass. That will be up to that can be asked at the most. So thank you all of you. If you have not subscribed the channel, if you feel your explanation is good, please do so and write your feedback. Thank you.